Welcome to the Pythagorean Theorem and its converse. You know what my favorite position in baseball is? Bat boy.
First thing we're going to talk about is a right triangle. That's a triangle with one angle measuring 90 degrees. So if you look at our example down here, we have triangle ABC. And in triangle ABC, we have one angle, angle C, that has this little red box here. This little red box denotes a right angle, meaning that the measure of angle C must be 90 degrees. Because this triangle has one angle measuring 90 degrees, triangle ABC must be a right triangle. Next vocabulary term is a hypotenuse. That's the side of the right triangle opposite the right angle. So down here, we again have a triangle with one angle measuring 90 degrees, meaning this must be a right angle, making triangle ABC a right triangle. Now, the side that is opposite that right angle, the side that is opposite the angle measuring 90 degrees, that is going to be your hypotenuse. So in this case, the side that is opposite angle C right here would be segment AB. Therefore, segment AB is your hypotenuse of right triangle ABC. Also note that the legs are going to be the sides that are adjacent to that right angle. So segment AC and segment BC would be called your legs of the right triangle. Now the Pythagorean theorem says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So the way this works, in our example down here, we have right triangle ABC. And in right triangle ABC, we have these side lengths. The measure of segment BC, we're going to call A because that's the side opposite angle A. The measure of segment AC, we're going to call B because that's the side opposite angle B. And then the measure of segment AB over here, we're going to call C because that's the side opposite angle C. Now what the Pythagorean theorem says is that if I were to take the sum of the squares of the lengths of the legs, so in this case, the lengths of our legs would be this lowercase a and this lowercase b. This lowercase b denotes the length of segment AC. This lowercase a denotes the length of segment BC, our legs. If we square the lengths of each of those legs and add them together, it has to equal the square of our hypotenuse, which in this case would be c squared. So that's where we get our Pythagorean theorem, a squared plus b squared is equal to c squared. Now the converse of the Pythagorean theorem says if the square of the lengths of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So this is just the converse of the Pythagorean theorem, as it says. The Pythagorean theorem stated if we had a right triangle, then the sum of the squares of the lengths of the legs has to equal the square of the hypotenuse. This converse just flips the if and the then, like converses do. So this says if the sum of the square of the lengths of the legs is equal to the square of the longest side, then you know it must be a right triangle. So in this case, if a squared plus b squared equals c squared, then we know triangle ABC must be a right triangle. Now the Pythagorean triples, those would be a set of non-zero whole numbers a, b, and c that satisfy the equation a squared plus b squared is equal to c squared. So this is pretty straightforward. A Pythagorean triple is just a set of non-zero whole numbers that satisfy the equation a squared plus b squared is equal to c squared. So some examples would be 3, 4, and 5. 3, 4, and 5 are a Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared, and they're all whole numbers. Same thing with 5, 12, and 13. These are all whole numbers, and they satisfy the equation because 5 squared plus 12 squared is equal to 13 squared. Same thing with 8, 15, and 17. 8 squared plus 15 squared is equal to 17 squared, and they're all whole numbers. Now, these are not the only Pythagorean triples. There are a lot more. These are just a few examples. Next thing we're going to talk about is the Pythagorean Inequality Theorems. So the first one says if the sum of the squares of the lengths of the two smaller sides of a triangle is less than the square of the length of the longest side, then the triangle is obtuse. So this is based on the converse of the Pythagorean theorem, which says if the square of the length of the longest side of your triangle is equal to the sum of the squares of the lengths of the other two sides, then it must be a right triangle. In this case, it's saying if the sum of the squares of the two smallest sides is less than the square of the longest side, then the triangle must be obtuse. Basically, if a squared plus b squared is less than c squared, then triangle ABC must be obtuse. And this makes sense because if we have one really big side, if c is really, really big, then the angle opposite that, angle c, must also be really, really big, meaning the triangle ABC must be obtuse. The second Pythagorean inequality theorem says if the sum of the squares of the lengths of the two smaller sides of a triangle is greater than the square of the length of the longest side, then the triangle is acute. So again, based on the converse of the Pythagorean theorem, this is saying now that if the sum of the squares of the two smaller sides of the triangle is greater than the square of the length of the longest side, or if a squared plus b squared is greater than c squared, where c is the longest side, then triangle ABC must be acute. And that makes sense because if we have the sum of the squares of the two smaller sides is greater than the square of our longest side, that means that this angle opposite our longest side has to be less than 90 degrees, making triangle ABC an acute triangle. Now let's talk about your C value. So this says when given three side lengths of a triangle, you always make C your greatest number. Then set A and B equal to the remaining two side lengths. So in this particular lesson, you're going to be asked to determine whether a triangle is right, acute, or obtuse based on three side lengths that you're given. Now in order to do this, you're going to have to plug them into the Pythagorean theorem where you have A squared plus B squared is equal to C squared. And you have to know which one to plug in where. The only one that matters is the longest side. The longest side must be plugged in for C. The other two sides can be plugged in for A or B. It doesn't matter. So in this case, if we're given three side lengths, 9, 12, and 20, you have to plug in 20 for your C value. 9 and 12 could be plugged in for A or B. It doesn't matter. If you're given three side lengths, 30, 22, and 25, you have to plug in 30 for your C value. 22 and 25 could be plugged in for A or B. It doesn't matter. If you're given three side lengths, 3, 4, and 1, you have to plug in 4 for your C value. 3 and 1 can be plugged in for A or B. It doesn't matter.
Get your mind ripped like Bane. It's example time.
Now example 1 says find the missing side length. So here we have a right triangle. We know it's a right triangle because of this little red box here. And we are given the two legs of our right triangle and we're trying to find the hypotenuse. So in order to find the missing side length of a right triangle, we use the Pythagorean theorem, which says a squared plus b squared is equal to c squared. In this particular instance, we're given our legs. Our legs represent A and B. And it doesn't matter which one you plug in for A or B. You'll get the same answer either way. Your hypotenuse has to be C though. So C is going to go in for C. That's convenient. 3, we can plug in for A. 4, we can plug in for B. You could have switched those. You'll get the same answer either way. Now we square these. 3 squared is going to be 9. 4 squared is going to be 16. 9 plus 16 is going to give you 25. Now we're given that C squared is equal to 25. To get C all by itself, we're going to have to get rid of the square. So we're going to square root both sides of the equation. Now when you square root a variable that is squared, on the other side, when you take the square root, you have to put a plus or minus. When you square root a square, those two things cancel each other out. On this side, when you square root 25, this just turns into 5. So you get C is equal to plus or minus 5. You put plus or minus 5 because technically in this equation up here, C could have been positive or negative 5. And if you square that, you still get 25. The only issue is our question is dealing with side lengths of a triangle. And you can't have negative 5 as a side length of a triangle, so we're just going to take our positive version, which is also called your principal root. So C is going to equal positive 5. Now part B, we are again given a right triangle. We know that because of this little red box down here. In our right triangle, we are given the hypotenuse, the side that is opposite the 90-degree angle, and we're given one of the legs, and we are tasked with finding the other leg. So anytime you are finding the missing side of a right triangle, you need to use the Pythagorean theorem. A squared plus b squared is equal to c squared. So now what we're going to do is we're going to plug in our legs for A and B. That means that 9 is going to go in for either A or B. It doesn't matter. I'm going to plug in 9 for A, and I'm going to plug in B for B because that makes sense. And then our C value has to be the hypotenuse, the side that is opposite the 90-degree angle. So 17, we're going to plug in for C. Now we need to solve for B. So what we do first is we square everything that needs to be squared. So 9 squared is going to be 81. 17 squared is going to be 289. Now we solve for B by subtracting 81 from both sides of the equation, and we get B squared is equal to 208. We then solve for B by getting rid of this square. The opposite of squaring something is square rooting it. So we're going to square root both sides. And anytime you square root a variable squared, that means that on the other side you have to put plus or minus. Here, the square and the square root are going to cancel each other out. And over here, the square root of 208, that's not a perfect square, but we can simplify that. Are there two numbers that multiply together to make 208, one of which is a perfect square? Yeah, 16 and 13. The square root of 16 times the square root of 13 gives you the square root of 208. So now I can simplify this. I picked 16 because that's a perfect square. Square root of 16 is going to be 4. Square root of 13, 13 is a prime number, so that just stays rad 13. So we get B is equal to plus or minus 4 rad 13. Again, we're dealing with side lengths of right triangles. So in this case, we're just going to take the positive version, which is also called your principal root, meaning B has to be 4 rad 13.
Poison ivy is the worst. You try.
Okay, doing the same thing here. We are finding the missing side length of a right triangle. Anytime you need to find the missing side length of a right triangle, you need to use the Pythagorean theorem. A squared plus b squared is equal to c squared. The a and the b are going to be the legs of your right triangle, meaning they are the sides that are adjacent to this 90-degree angle, so the x and the 8. Your c value has to be your hypotenuse, the side that is opposite the 90-degree angle. So 17 has to go in for c. Your a and your b, it doesn't matter which is x or which is 8. I'm just going to plug in x for a and 8 for b. Now what I can do is simplify this and solve for x. So I square the 8 and the 17 and I get 64 and 289. I then solve for x by subtracting 64 on both sides and I get x squared is equal to 225. I then solve for x by getting rid of the square, so I'm going to have to square root both sides of the equation. Anytime you square root a variable squared, you have to put plus or minus on the other side. But we already said that we are just using the positive version today because we're dealing with side lengths of right triangles. So x is going to have to equal the principal root of 225, which is 15. Part B, doing the same thing, we are finding the missing side length of a right triangle, meaning we need to use the Pythagorean theorem. A squared plus b squared is equal to c squared. The a and the b are going to be the length of your two legs, the sides adjacent to your 90-degree angle. The hypotenuse has to be your c value, the side opposite the 90-degree angle. So 15 is going to go in for c. K and 12, it doesn't matter which one goes in for a or b. You'll get the same answer either way. I plug in 12 for a, I'm plugging in k for b. Now I solve for k, so I have to square the 12 and the 15. I then solve for k by subtracting 144 on both sides, and I get k squared is equal to 81. I then get k all by itself by getting rid of the square, so I have to square root both sides, and anytime you square root a variable that is squared, you have to put plus or minus on the other side. But we said today we're just dealing with the positive version, the principal root, because we're dealing with side lengths of triangles, which can't be negative. So k has to equal 9. Lastly, doing the same thing, find the missing side length of right triangle. So we need to use the Pythagorean theorem. A squared plus b squared is equal to c squared. The a and the b are going to be the lengths of your two legs. Doesn't matter which one goes in for which. The c value has to be your hypotenuse, the side opposite the 90-degree angle. So I'm going to plug in w for c, and I'm going to plug in 20 and 5 for a and b respectively. Now what I can do is solve for w by squaring the 20 and the 5, adding them together, and then getting w all by itself by getting rid of the square, so I have to square root both sides. Anytime you square root a variable squared, you got to put plus or minus on the other side. But again, we're just dealing with the principal root today, the positive version, because we're dealing with side lengths of triangles. So w is going to equal the square root of 425, which is not a perfect square. So we're going to have to break it up into two separate radicals that multiply together to make rad 425, one of which is a perfect square. So what perfect square goes into 425? That would be 25. So rad 425 we're going to rewrite as rad 25 times rad 17. We picked 25 because it's a perfect square, so the square root of 25 is going to be 5. Rad 17 stays rad 17. So w is going to equal positive 5 rad 17. Now example 2 says determine if the following triangles are right triangles. If not, specify whether it's acute or obtuse. So this is where the converse of the Pythagorean theorem and the Pythagorean inequality theorems come in. Remember, if a squared plus b squared is equal to c squared, we know it's a right triangle. If a squared plus b squared is less than c squared, then we know it's going to be an obtuse triangle. If a squared plus b squared is greater than c squared, we know it's going to be an acute triangle. So the way we're going to do this is we're going to start with the Pythagorean theorem. A squared plus b squared is equal to c squared. And we're going to plug in our values and then figure out what each side is equal to and adjust our equal sign if need be. So our a and our b value are going to be the two smaller sides because our c value has to be the longest side of the triangle. So 29 has to go in for c, and then it doesn't matter which is a or b in terms of 20 and 21. So I'm going to plug in 20 for my a value and 21 for my b value. 29 has to be c. Now I'm going to simplify each side and determine if a squared plus b squared is equal to c squared, less than c squared, or greater than c squared. So what's 20 squared? That's 400. 21 squared is 441. If I add these together, I end up getting 841, which is exactly what 29 squared is equal to. Because a squared plus b squared is equal to c squared, we know that this triangle up here must be a right triangle by the converse of the Pythagorean theorem. Part B, doing the same thing. We're going to start with our Pythagorean theorem. A squared plus b squared is equal to c squared. And we're going to adjust our equal sign if need be. Remember, our a and our b value are going to be the two smaller legs because our c value has to be the longest side of our triangle. So 6 is going to go in for my c, and then it doesn't matter which goes in for a or b in terms of 2 and 5. So I plug those in, and now I simplify and figure out if these two sides are equal to one another. 2 squared is equal to 4, 5 squared is equal to 25, 6 squared is equal to 36. I then add add the 4 and the 25, and I get 29. Now, 29 does not equal 36. Because of that, we know this cannot be a right triangle. The question is it obtuse or is it acute? Well, the way we figure that out is with the Pythagorean Inequality Theorems. If we know that a squared plus b squared is less than c squared, we know it's obtuse. If we know a squared plus b squared is greater than c squared, we know it's acute. Well, in this particular instance, it looks like a squared plus b squared is less than c squared, meaning that this triangle up here must be obtuse.
Don't be a two-face. You try.
Okay, doing the same thing here. I need to figure out if a squared plus b squared is equal to c squared. If it is, it's a right triangle. If a squared plus b squared is less than c squared, it's obtuse. If a squared plus b squared is greater than c squared, then we know it's acute. So we start with our Pythagorean theorem. A squared plus b squared is equal to c squared. We're going to plug in our two shorter legs for a and b. Doesn't matter which one goes in for which in terms of 18 and 24. I'm going to plug in 18 for a, 24 for b. I do that because my longest side, 28, has to go in for c. Now I can simplify and see if these two sides of the equation are equal. 18 squared is going to equal 324, 24 squared is 576, and 28 squared is 784. I then add these two together and I get 900, which is not equal to 784, meaning a squared plus b squared does not equal c squared, meaning that this triangle cannot be a right triangle. But the question is it obtuse or is it acute? Well, it's going to be an obtuse triangle if a squared plus b squared is less than c squared. It's going to be an acute triangle if a squared plus b squared is greater than c squared. In this particular instance, a squared plus b squared is greater than c squared, meaning that this triangle up here must be acute. Doing the same thing for part B. I'm going to start with my Pythagorean theorem. A squared plus b squared is equal to c squared. The two shorter legs are going to go in for a and b. Doesn't matter which is which in terms of 5 or 12. I'm going to plug in 12 for my a value and 5 for my b value. I do that because my longest side, 13, has to be my c value. So I plug that in there. Now I simplify each side and determine if they are equal. If they are equal, then it's a right triangle. If they're not, then it's either going to be acute or obtuse. So 12 squared is going to be 144, 5 squared is going to be 25, and then 13 squared is 169. I then add these two together and I get 169 is equal to 169 because a squared plus b squared is equal to c squared. That means that this triangle up here must be a right triangle. Part C, doing the same thing. I start with my Pythagorean theorem. My two shorter legs are going to go in for A and B. Doesn't matter which is which, so I'm going to plug in 5 for my A value, 7 for my B value. I do that because my longest side, 10, has to go in for my C value. Now what I do is simplify each side to determine if they are equal. If they are, it's a right triangle. If they're not, it's either obtuse or acute. So I square each of these numbers. 5 squared is going to be 25, 7 squared is going to be 49, 10 squared is going to be 100. Now 25 plus 49 is going to give you 74, which is not equal to 100. Because of that, we know that this is not going to be a right triangle. So we now need to figure out, is it acute or obtuse? Well, if a squared plus b squared is less than c squared, then we know it's an obtuse triangle. If a squared plus b squared is greater than c squared, we know it's acute. In this particular instance, a squared plus b squared is less than c squared. Because of that, we know this triangle up here must be obtuse. Part D, doing the same thing. We're going to start with our Pythagorean theorem. A squared plus b squared is equal to c squared. We're going to choose our two shortest sides to go in for a and b down here. Doesn't matter which is which in terms of 15 or 8. You'll get the same answer either way. We do that because our longest side, 16, has to go in for c. Now I square each of these and determine if a squared plus b squared is equal to c squared. If it is, it's a right triangle. If it's not, it's either acute or obtuse. So we square each of these. 8 squared is 64, 15 squared is 225, and 16 squared is 256. We then add these together and we get 64 plus 225 is 289, which is not equal to 256. Because of that, we know this triangle cannot be a right triangle. So it's either going to be acute or obtuse. So the question is, which is it? Well, if a squared plus b squared is less than c squared, then we know it's obtuse. If a squared plus b squared is greater than c squared, we know it's acute. In this particular instance, a squared plus b squared is greater than c squared. Because of that, we know this is going to be an acute triangle. Now, word problem says, according to the ladder company's safety regulations, the distance from the base of a ladder to a wall that it leans against should be at least 1/4 of the ladder's total length. You are given a 20-foot ladder placed against a wall at a job site. If you follow the company's safety regulations, what is the maximum distance up the wall the ladder will reach to the nearest 1/10 of a foot? So step 1 in a word problem, we're not scared, we can do this. Step 2, we need to define our variables. So what is this question asking us? It's asking us what is the maximum distance up the wall the ladder ladder will reach. So what does this even look like? Well, we need to make a sketch to help us out. So we have a wall and a ladder that's leaning up against it. And as you can see, this ladder that is leaning up against the wall that is perpendicular to the ground creates a right triangle, and that's no coincidence. We're going to use that to solve this particular question. So again, we're defining our variables. What is the maximum distance up the wall that the ladder will reach? So this distance right here up the wall, we'll call that A. So A is going to be the distance up the wall that the ladder is going to reach. We also have two other variables in our triangle. We have this side and this side. Well, since it's a right triangle, why not make it B and C? B will be the distance that the base of the ladder is away from the wall. And then the last unknown side of our right triangle would be the hypotenuse, the length of the ladder. We'll call that C in this case. So now that we've labeled our figure with all of our variables, we can write our equation. So how are all of these variables related? Well, this is a right triangle. So we know that A squared plus B squared has to equal C squared. But that doesn't help us. We can't solve for A this way because we don't have a B or a C. Well, couldn't we figure that out from what we're given up here? Yeah, we're given that the ladder is 20 feet long, meaning our C value has to be 20 feet. What about our B? Well, there were some safety regulations up here that said the distance from the base of the ladder to the wall that it leans against should be at least 1/4 of the ladder's total length. So in this particular instance, since the ladder's total length is 20 feet, if we were to take that and find 1/4 of that length, so either divide it by 4 or multiply it by 1/4, we would get that the minimum distance that the base of the ladder should be away from the wall is equal to 5 feet. So now we have our B and our C, meaning we could solve for A. So we're going to plug in 5 for our B, 20 for our C. So now we solve this equation just like we have been doing. We're going to square the 5 and the 20. We then solve for A by subtracting 25 on both sides and then square rooting both sides to get A all by itself. Remember, when you square root a variable squared, you got to put plus or minus on the other side. Now the only issue is that here we're dealing with a side length up a wall, meaning it's not going to be negative. So we're going to use the principal root. We're going to use the positive version of our square root. Now 375 is not a perfect square, so we have to break it up. Oh, no we don't, because the answer says, what is the maximum distance up the wall the ladder will reach to the nearest 1/10 of a foot? When you see this, it means you're rounding, meaning that you could just plug in the square root of 375 into your calculator, round that number to the nearest 1/10 of a foot, and you get that A has to be approximately 19.4. Now, you can't just write A as approximately 19.4 as your answer. You were asked a question. What is the maximum distance up the wall the ladder will reach to the nearest 1/10 of a foot? So you're going to say that the ladder will reach a maximum distance of 19.4 feet up the wall.